Okay, we're ready to go. We go back to the PowerPoint and we look at connective tissue, which is made up of cells like cartilage cells, bone cells, and the extracellular matrix, the jelly that the cells produce and that they are positioned, for instance, in cartilage at the end of bones, or cartilage in your nose and your ears and so on. So there's cells and extracellular matrix. What do connective tissues do? Structure, transport fluid and solutes, protect, connect tissues, store fat, and microorganism defense. So how do we classify connective tissue? We have connective tissue proper. We have fluid connective tissues like blood. We have supporting connective tissue like the tissue just underneath your dermis will be a supporting connective tissue. So what are the types of connective tissue? Connective tissue proper, loose connective tissue, dense. This loose connective tissue is found immediately below the dermis of the skin, and it's there to hold the skin onto the surface of the body. Tendons and ligaments are this type of tissue. Blood and lymph are fluid connective tissues. And then we have supporting tissues like cartilage and bone. The connective tissue, again, has cells and protein fibers and a matrix, which is the substance, the fluid substance that the cells and fibers are embedded into. So there's migrating cells in connective tissue. Fibroblasts make new protein fibers, for instance, and new matrix. Macrophages patrol to attack any type of bacteria that gets in, but also to remove dead cells. Mast cells are involved and also in the immune response. Okay, so we have collagen fibers, reticular fibers, and elastic fibers. Okay, so we're recording this, I hope. Are we recording? Yes, we are. Okay. So let's look at these connective tissue. This is loose connective tissue. This is found just below the dermis of the epithelium. It holds the tissue in place, the dermis above it. It contains antibody-producing cells, fat cells, white blood cells, free macrophages, mast cells. So you have the cells of the cartilage itself, which is in the ground substance. And they don't give an example of, oh yeah, here it is, a fibroblast. That's going to make these fibers and make this cartilage. So there'll be cells to produce antibodies, cells to consume the bacteria that may get in here or help clean up dead cells. So loose connective tissue, which we just started, and it's beneath the dermis. Adipose tissue is fat tissues. And then we talked about tendons and ligaments for dense connective tissue. Loose connective tissue can surround fat cells. It also is just below the dermis. It's called loose because it has the matrix, the extracellular jelly, so to speak, that contains cells and fibers, and they're not packed close to one another. Adipose tissue is fatty tissue. This is how you store fat. It has a very distinctive appearance. It looks like a little network. That's about it. Dense connective tissue is dense. Notice you can't see a matrix. All the fibers are packed close to one another. So a tendon that holds muscle to bone. Fluid connective tissue is blood and lymph. The bone is also a connective tissue. That's cartilage. Osteocytes make collagen, deposit calcium salts. Chondrocytes make the fibers and a firm gel, the extracellular matrix. So cartilage doesn't have any blood supply. It has a membrane called the perichondrium. There's hyaline, elastic, and fibrocartilage. Hyaline cartilage is found at the end of all bones. This is the extracellular matrix. The cells grow, secrete this gelatinous matrix. And there are collagen fibers also. So hyaline cartilage is at the end of all bones at all joints. Elastic cartilage is just like hyaline cartilage, except it's full of fibers, elastic fibers. Your ear is the primary location of that elastic cartilage. Fibrocartilage is layers of collagen with chondrocytes. It's dense. The intervertebral disc is a primary location. Bone has collagen fibers, calcium salts to harden the bones and resist compression. We'll find out what a canaliculi is in a moment. Osteocytes are bone cells, and periosteum is the covering around the outside of the bone. So this is compact bone. Notice it's made of these columns called the Haversian system. And it has a central canal where blood vessels and nerves are found. The little canals connecting the osteocytes, which are these little cells, those are little canals that allow the osteocytes to exchange materials to get oxygen and food from the blood vessels to get rid of waste. So the canaliculi are little canals that connect the osteocytes. The osteocytes form these circular layers called lamellae, and this entire structure is a Haversian system. Haversian. Okay, let's stop there. And we'll come back to membranes. Stop recording. Stop recording.